Welcome to Fall Asleep Channel. Tonight, we explore our friends, dogs, a calm narrative with interesting facts. If you enjoy peaceful stories like this, you are warmly invited to subscribe and return whenever you need to slow down. Now allow yourself to get comfortable and enjoy quiet and pleasant rest. Let's begin. Air carries information long before form becomes visible. Subtle chemical traces move across surfaces and through narrow currents, changing concentration with humidity, temperature, and time. In domestic canines, the nasal cavity contains layered structures that expand surface area, supporting a receptor field counted in the hundreds of millions. This density allows discrimination between overlapping signals that would blend together for many other mammals. Scent does not simply mark presence. It forms gradients that describe direction, age, and recent movement. Orientation emerges through repeated sampling, short inhalations, slight head adjustments, small changes in pace. Space becomes a shifting field of chemical probability rather than a fixed map of objects. Memory stabilizes this field. Familiar trails reduce uncertainty. Unfamiliar mixtures elevate attention until patterns repeat. The olfactory cortex occupies a proportionally large region of the brain, supporting continuous integration without conscious effort. This dominance does not exclude other senses. It coordinates with hearing and vision to create redundancy. When one channel weakens, another fills the gap. Sound enters quickly. Ears rotate independently, scanning for direction and distance. Sensitivity extends into higher frequencies than human hearing, allowing detection of faint mechanical movement. Repeated sound patterns fade into background. Irregular changes sharpen posture and muscle tone briefly, then settle when predictability returns. Vision contributes primarily through motion and contrast, rather than fine detail. Color discrimination remains limited, centered around blue and yellow wavelengths. Low light sensitivity supports activity during dawn and dusk margins when thermal load decreases and scent persists more reliably than visual cues. Together, these systems create layered stability. Sensing remains distributed rather than centralized. No single channel dominates for long. Movement expresses this integration. The skeleton supports endurance rather than extreme flexibility. The spine absorbs load and transfers force efficiently across sustained travel. Shoulder joints allow a long, economical stride. Weight distributes across 4 limbs, reducing localized stress and enabling steady pacing. Gait shifts smoothly between walk, trot, and run depending on terrain and energy state. Respiratory rhythm synchronizes with stride during faster movement, stabilizing oxygen delivery. Muscle fibers balance endurance and power rather than maximizing either. Paws absorb vibration through dense pads rich in nerve endings, providing texture feedback before full weight commits. Claws remain exposed, offering constant traction on soil, gravel, and uneven ground. Balance remains regulated by vestibular input and tail positioning, especially during turning and uneven surfaces. Posture adjusts first when conditions change. Stride length shortens. Center of mass shifts. Stability returns without delay. Thermoregulation overlays every activity cycle. Heat dissipates primarily through panting as airflow passes across moist surfaces. Sweat glands exist mainly in the paw pads and contribute minimally. Fur acts as insulation, trapping air in cold conditions and buffering heat exchange. Some individuals carry dense undercoats that retain warmth. Others dissipate heat more readily due to coat structure and body size. Behavior bridges physiology and environment. Shade becomes preferred during heat load. Water intake increases with exertion and dry air. Activity timing shifts toward cooler hours. Rest fragments more frequently when thermal stress rises. Hydration integrates tightly with cooling. Drinking remains direct and frequent when conditions demand it. Saliva contributes to evaporative heat loss during panting, linking oral function with temperature regulation. Digestion supports flexible energy use. Unlike strict carnivores, domestic canines retain enzymatic capacity for starch processing through increased amylase expression. Protein remains central for tissue maintenance and muscle function, yet carbohydrate handling supports glycogen storage in the liver and muscles. Meals may be larger and less frequent than in small solitary hunters, shaped by routine and activity patterns. Hunger rises gradually rather than abruptly. Expectation can shape appetite timing through association, but internal regulation remains decisive. Gastrointestinal transit balances nutrient extraction with efficiency. The microbiome contributes to metabolic stability and immune modulation. Water balance shifts rapidly with exertion and temperature. Mild dehydration alters endurance and attention before overt signs appear. Rest and sleep organize recovery without full disengagement. In stable environments, longer nighttime rest may occur, yet alertness remains easily reversible. Short doses appear throughout the day following activity or feeding. Sensory thresholds rise during rest, filtering background noise while preserving rapid reorientation when patterns shift. Hearing often remains partially active, maintaining environmental sampling even during deeper phases. Social coordination adds another regulatory layer. This species evolved within group contexts where spacing, timing, and shared movement reduced risk and improved resource access. Posture conveys internal state through orientation, tail carriage, and muscle tension. Facial musculature shifts with arousal, yet interpretation remains grounded in physiology rather than emotional projection. Vocal output appears more frequently than in many solitary mammals. Barking, whining, and howling function as distance signals shaped by breed selection and learning history. Acoustic patterns vary widely across lineages, reflecting human-directed selection rather than ancestral necessity. Scent marking remains fundamental despite vocal flexibility. Urine and glandular secretions persist in the environment, conveying identity and reproductive status long after departure. Chemical signaling reduces the need for direct contact and supports spatial organization. Learning operates through association and repetition. Reinforced outcomes stabilize patterns more effectively than force. Memory preserves routes, resting sites, feeding locations, and social spacing. Familiar sequences lower stress load by reducing prediction error. Sudden environmental change elevates vigilance. Pacing increases. Scanning intensifies. Rest fragments until new regularities establish. Play functions as structured motor rehearsal and arousal regulation. Chasing, tugging, and repeated approach withdrawal cycles refine coordination, bite control, and timing. In young individuals, these patterns also calibrate social thresholds and spacing tolerance. Development begins with sensory limitation. Newborn pups arrive with closed eyes and ears, relying primarily on touch, warmth, and scent. Sensory systems mature over weeks. Exploration expands as motor control strengthens. Maternal care provides warmth, feeding, and protection, while early learning accumulates through proximity and repeated exposure. Growth proceeds rapidly in the first months, establishing neural circuits that support locomotion, social coordination, and environmental mapping. Aging gradually reshapes capacity. Muscle mass redistributes. Joint elasticity may decline. Reaction speed softens slightly. Endurance decreases. Energy economy becomes more important than output. Sensory thresholds shift, yet redundancy preserves orientation. If hearing narrows, scent and memory compensate. If vision changes, posture and distance increase safety margins. Behavior simplifies under constraint. preserving core regulation rather than maximizing range. Throughout all of these layers, regulation remains distributed. Sensing guides adjustment. Adjustment reshapes movement. Movement modifies future sensing. No central command directs the system. Coherence emerges through repetition and constraint. Sound arrives and fades. Scent persists and disperses. Posture responds before motion. Rest returns whenever energy demands it. Activity resumes when gradients invite another cycle of orientation and response. As cycles repeat, the surrounding environment becomes increasingly predictable through accumulated exposure. Paths compress into habitual routes. Resting sites stabilize near thermal balance and low disturbance. Feeding locations anchor daily movement. These patterns reduce cognitive and metabolic cost by narrowing the range of uncertainty. Attention remains available for deviation rather than constant scanning. Scent fields reinforce this stability. Repeated marking blends individual chemistry with place, creating recognizable gradients that persist across hours or days. These gradients guide orientation even when visual landmarks shift. Memory integrates this chemical structure with spatial layout, allowing rapid re-entry into familiar zones without exploratory overhead. Auditory landscapes follow similar adaptation. Constant background sounds dissolve into baseline. Irregular variation briefly elevates alertness, then subsides once pattern repeats. This selective filtering preserves clarity while conserving energy. Visual input remains secondary but supportive. Motion in peripheral space draws orientation. Stationary features fade unless change occurs. Contrast sensitivity assists in detecting movement against low light or textured backgrounds. In low illumination, visual acuity softens while scent and sound maintain spatial continuity. Movement remains economical within these stabilized fields. Stride length adapts subtly to surface resistance and incline. Limb loading redistributes to minimize joint strain. Small postural changes precede directional shifts, smoothing transitions and preventing abrupt energy spikes. Endurance benefits from this continuity. Respiration and cardiac output synchronize with locomotor rhythm during steady travel, maintaining oxygen balance without overshoot. Recovery follows quickly when movement slows, allowing repeated bouts without cumulative fatigue. Thermoregulatory behavior remains closely coupled to environment. Microclimates within the same space influence positioning. Cool surfaces attract during exertion. Insulated areas support rest during lower ambient temperature. Shade and airflow modify heat exchange without requiring physiological escalation. These choices reduce reliance on panting alone, conserving hydration. Water consumption increases naturally with exertion and dry conditions, maintaining plasma volume and thermodynamic stability. Elimination patterns also reflect regulation. Timing and location of urination and defecation follow routine, reducing sensory uncertainty and reinforcing spatial predictability through chemical markers. These markers communicate presence and timing indirectly, shaping movement of other individuals without direct interaction. Social spacing adjusts continuously within shared environments. Proximity tolerance increases with familiarity and decreases with unpredictability. Approach and withdrawal establish dynamic boundaries that remain fluid rather than fixed. Posture mediates these negotiations through angle orientation and muscle tone. Direct confrontation remains rare when spacing and timing remain readable. Vocal output escalates primarily when distance regulation fails or when external novelty intrudes. Acoustic signaling expands spatial influence beyond immediate presence, restoring alignment when visual or chemical cues are insufficient. Learning refines these patterns through consequence. Behaviors that reduce internal load stabilize. Those that increase cost fade through lack of reinforcement. Memory supports this optimization by retaining associations that consistently predict outcome. Forgetting removes outdated correlations, preserving responsiveness. Play continues beyond juvenile stages as a maintenance process. It preserves coordination, elasticity, and recalibrates sensory motor coupling. Absence of such outlets may increase baseline arousal, expressed through pacing or repetitive movement rather than intent. Environmental complexity buffers this effect by providing varied texture, height, and scent input. Sleep cycles integrate recovery into this regulatory loop. Deeper phases consolidate neural patterns, while lighter phases preserve environmental sampling. Arousal thresholds remain adjustable. Excessive noise or irregular light fragments rest until consistency returns. Circadian rhythm persists even under artificial schedules, guided by internal clocks distributed across tissues. Feeding, timing, light exposure, and temperature modulate this rhythm without overriding it entirely. Health reflects cumulative alignment rather than isolated events. Minor strain resolves through redistribution of load and increased rest. Immune activation redirects energy temporarily toward repair. Behavior simplifies until recovery restores capacity. Persistent imbalance gradually reshapes structure before overt dysfunction appears. Aging magnifies this economy. Recovery slows. Tolerance for variability narrows. Reliance on familiar patterns increases. Preferred locations dominate activity. Exploration yields to observation. This shift conserves energy while preserving coherence. Sensory engagement remains present, though bandwidth reduces. Regulation continues as long as integration remains viable. Beyond individuals, group dynamics reflect aggregated regulation. Density influences spacing tolerance. Resource distribution shapes movement overlap. Urban environments introduce continuous noise and altered light cycles that elevate sensory load. Adaptation occurs through modified timing and route selection rather than through new structural change. Domestication layers predictability onto ancestral systems without altering core regulatory logic. The same loops persist. Sensing informs adjustment. Adjustment reshapes movement. Movement alters future sensing. Continuity emerges through repetition rather than intention. Gradients shift. Patterns settle. Activity rises and fades. Rest returns when demand accumulates. And alignment persists quietly as long as energy flows through a body shaped for endurance, coordination, and continuous adjustment within changing conditions. Over longer spans, the accumulated effect of these adjustments becomes visible not as goal or preference, but as stable pattern. Daily routes require less sampling. Resting posture optimizes pressure distribution across joints and muscle groups. Favored surfaces match thermal and tactile comfort without conscious selection. The body settles into efficiencies shaped by repetition rather than design. Nothing maximizes output. Everything supports continuity, sufficient speed, sufficient awareness, sufficient recovery. Excess would increase cost and reduce flexibility. Restraint preserves resilience. Sensory thresholds continue to recalibrate with age and environment. Olfactory sensitivity remains high across lifespan, anchoring orientation when other channels soften. Auditory range may narrow slightly, yet directional accuracy persists. Visual contrast detection remains effective even as fine acuity shifts. Redundancy maintains function through overlap. When one channel weakens, others compensate without disruption. Regulation depends on this distributed buffering. Nutrition supports these long-term adaptations. Consistent intake stabilizes muscle tone, coat quality, and immune balance. Irregularity increases variability that the system absorbs until thresholds approach. Long-term excess alters load distribution across joints and cardiovascular demand. Correction remains possible while energy reserves permit behavioral adjustment. Once limits narrow, strategy simplifies toward conservation. This simplification reflects prioritization under constraint rather than decline. Hydration continues to shape endurance and thermoregulation. Mild deficits alter panting efficiency and attention before visible signs emerge. Correction restores function gradually through consistent access rather than rapid intake. Elimination patterns remain linked to routine and environmental familiarity. Disruption elevates scanning and delays release until predictability returns. Social proximity continues to modulate internal state throughout life. Tolerance bands expand or contract with experience density and health. Interaction remains negotiated through timing and spacing rather than dominance hierarchy. Facial musculature and tail position continue to signal arousal level and directional intent. Sound remains supplemental rather than primary when posture suffices. Silence returns quickly once alignment stabilizes. Learning persists across lifespan, though association formation slows slightly with age. Repetition strengthens new patterns. Old patterns remain durable. Environmental change requires longer adjustment periods, but integration still occurs through consistency. Enrichment maintains neural engagement without overstimulation by providing varied sensory input and controllable exploration. Boredom reflects underutilized capacity rather than emotional lack. Engagement restores regulatory balance by activating dormant pathways. Sleep architecture evolves with age. Deeper phases shorten, lighter phases lengthen. Responsiveness remains preserved. Fragmented rest compensates through increased total duration. Circadian timing remains anchored by internal clocks despite altered sensitivity to light and routine. Health events temporarily reorganize priorities. Movement reduces, warmth is sought, appetite adjusts. Immune activity reallocates energy toward repair. Recovery reverses these shifts gradually through repetition rather than signal. Veterinary handling introduces unfamiliar sensory load. Elevated arousal follows. Extended grooming, pacing, or withdrawal restore equilibrium once novelty fades. End stages of life narrow margins further. Movement minimizes. Favored zones dominate activity. Exploration ceases. Sensory engagement remains present though quiet. Integration persists until energy no longer supports coordination across systems. Continuity thins without announcement. Beyond individuals, environments retain imprints of repeated regulation. Compacted soil-worn paths, persistent scent fields. These traces alter future movement, reducing uncertainty and metabolic cost. Regulation therefore extends outward, shaping surroundings that in turn shape behavior. No level commands the other. Both participate in reciprocal adjustment. Across all contexts, the same pattern holds. Sensing informs adjustment. Adjustment reshapes structure. Structure filters future sensing. The loop operates without endpoint or commentary. Light shifts. Sound outlines distance. Scent carries memory. Movement balances energy. Rest restores capacity. Repetition stabilizes behavior. Variation introduces change. The system remains open and quietly persistent, maintaining alignment within whatever conditions remain as long as gradients exist, and energy continues to circulate through a body organized for endurance, coordination, and continuous adaptation. As alignment persists, the surrounding field becomes increasingly economical to interpret. Fewer samples are required to confirm stability. Fewer corrections are needed to maintain balance. Internal prediction improves not through abstraction, but through repeated exposure to consistent outcomes. Surfaces become familiar through pressure and texture. Air currents reveal open and enclosed spaces. Lingering chemical traces indicate recent movement even when no sound remains. These layered cues reduce uncertainty and lower baseline arousal, allowing energy to remain available for change rather than vigilance. Attention narrows when patterns hold, widens when deviation appears. This modulation conserves metabolic resources while preserving responsiveness. The nervous system favors proportional response rather than maximal reaction. Small disturbances generate small adjustments. Only sustained inconsistency escalates output. This scaling prevents fatigue and protects long-term stability. Muscular systems mirror this logic. Tone remains low during rest, yet rises rapidly when movement initiates. Elasticity preserves joint integrity by distributing load across connective tissue rather than concentrating stress. Frequent low-intensity movement maintains circulation and nutrient delivery without triggering recovery debt. Stretching occurs spontaneously following periods of stillness, restoring fiber length and neural feedback without conscious sequencing. Posture remains fluid rather than fixed, continuously adapting to surface incline and pressure distribution. Digestion synchronizes with activity and rest. Nutrient absorption aligns with blood flow and hormonal signaling, directing energy toward tissue maintenance during low demand and toward movement during active phases. The liver buffers short-term variation through glycogen storage and release, stabilizing glucose availability without sharp fluctuation. Microbial populations within the gut adjust gradually to dietary patterns, supporting metabolic consistency rather than rapid change. Hydration status influences cardiovascular efficiency and thermoregulation in parallel. Slight deficits elevate heart rate and panting effort before overt thirst signals dominate. Restoration occurs progressively as plasma volume normalizes. These micro-adjustments remain largely invisible, yet shape endurance and comfort continuously. Elimination behavior integrates into spatial mapping. Consistent locations reduce sensory ambiguity and reinforce routine boundaries. Disruption elevates scanning and delays release until predictability returns, maintaining internal coherence in uncertain contexts. Social presence continues to influence regulatory thresholds. Shared movement synchronizes pacing. Proximity modulates arousal. Separation restores baseline when sensory load accumulates. These dynamics operate without hierarchy when spacing and timing remain readable. Misalignment resolves through distance rather than escalation. Acoustic output expands reach when visual or chemical cues cannot resolve spacing quickly. Once alignment restores, sound diminishes, preserving low sensory load. Learning remains embedded within this loop. Associations strengthen when they reduce effort or restore predictability. Ineffective responses extinguish through lack of reinforcement rather than correction. Memory remains selective, retaining patterns that reliably forecast outcome while releasing outdated correlations. This filtering prevents saturation and preserves adaptability. Play remains an outlet for recalibration throughout adulthood. Variable motion refreshes coordination, timing, and sensory integration. Absence of such variability may elevate baseline tension, expressed through repetitive pacing or increased vocalization as regulatory compensation rather than intent. Environmental complexity buffers this effect by offering graded challenge and controllable novelty. Circadian regulation continues to integrate light temperature feeding and social rhythm into internal timing. Internal clocks distributed across tissues resist abrupt override, smoothing transitions when schedules shift. Misalignment fragments rest temporarily until new cues stabilize. Health reflects cumulative success of these interactions rather than isolated variables. Stable environments allow recovery reserves to rebuild. Chronic unpredictability elevates metabolic cost and erodes margin over time. Resilience emerges not from resistance but from the capacity to absorb variation without loss of coherence. Aging gradually compresses these margins. Recovery slows. Tolerance for irregularity narrows. Dependence on familiar gradients increases. Exploration yields to monitoring, yet regulation persists through simplification rather than collapse. Favored routes and resting sites dominate activity. Sensory engagement remains sufficient to maintain orientation. Integration continues as long as energy supports coordination across systems. Beyond individuals, the same principles scale across populations. Resource distribution shapes spacing. Noise and light modify timing. Urban density elevates sensory load while predictable schedules partially compensate. Domestication alters context without altering mechanism. The regulatory architecture remains intact. Sensing guides adjustment. Adjustment reshapes movement. Movement modifies future sensing. Continuity emerges through repetition rather than directive. Gradients shift and settle. Activity rises and fades. Rest returns when demand accumulates. And alignment continues quietly within a body organized for endurance coordination and distributed regulation as conditions change without announcing completion or resolution. As repetition deepens, the boundary between internal state and external condition becomes less distinct. Temperature gradients shape posture before discomfort registers. Airflow alters positioning long before heat accumulates. Faint shifts in scent density redirect movement without visible pause. These micro-alignments maintain equilibrium through anticipation rather than correction. The nervous system predicts near-future input based on recent consistency, allowing posture and pacing to adjust ahead of demand. This predictive smoothing reduces spikes in effort and preserves metabolic reserve. Cardiovascular response follows the same principle. Heart rate rises gently with sustained movement and settles quickly during pauses, maintaining efficient oxygen delivery without prolonged elevation. Capillary exchange adapts locally to tissue demand, redistributing flow toward active muscle and away from resting regions. Recovery remains rapid because peaks remain shallow. Respiration aligns with this rhythm. Inhalation depth increases during steady travel. Panting transitions smoothly when thermal load rises. Airflow supports both oxygen exchange and heat release without abrupt shifts. Connective tissue adapts gradually to repeated load. Collagen alignment follows habitual stress lines, increasing durability while preserving flexibility. This structural tuning reflects history rather than design. Surfaces walked most often shape joint angle preference and muscle recruitment patterns. The body learns terrain through tissue remodeling as much as through neural memory. Sensory thresholds continue to drift subtly across seasons and age. Olfactory discrimination remains robust, anchoring spatial continuity when visual contrast changes with lighting or weather. Auditory localization retains precision even if absolute sensitivity narrows slightly. Visual motion detection remains effective for maintaining distance regulation and obstacle avoidance. Redundancy preserves orientation through overlap, preventing single-point failure. Nutrition interacts with this stability. Consistent macronutrient availability supports muscle repair, immune function, and neural signaling. Irregular intake introduces variability that the system buffers until cumulative load exceeds margin. Long-term excess alters mass distribution and joint stress, reshaping gait before overt strain appears. Gradual adjustment through moderated activity and intake restores balance when possible. Hydration continues to modulate endurance and thermoregulation in parallel. Plasma volume influences cardiac efficiency. Saliva production supports evaporative cooling. Minor imbalance expresses as earlier fatigue rather than immediate distress. Elimination timing remains coupled to routine and spatial familiarity. Predictable locations reduce sensory ambiguity and support relaxed release. Unfamiliar contexts delay elimination until environmental mapping restores confidence. This behavior maintains internal coherence by preventing vulnerability during uncertainty. Social modulation persists as an ongoing calibration. Shared pacing synchronizes movement and reduces scanning load. Proximity increases sensory input while also providing redundancy through group awareness. Separation lowers cumulative load when stimulation accumulates. These adjustments occur fluidly without fixed hierarchy as long as spacing remains readable. Acoustic signaling expands influence when other channels cannot resolve distance quickly. Once alignment stabilizes, silence resumes, preserving low baseline arousal. Learning remains active through consequence rather than instruction. Successful adjustments stabilize through repetition. Ineffective ones fade without reinforcement. Memory remains economical, retaining only patterns that consistently predict outcome. This selective retention preserves responsiveness and prevents saturation. Play continues to serve recalibration across the lifespan. Varied motion refreshes coordination, timing, and sensory coupling. Absence of variability elevates baseline tension, expressed through increased pacing or vocal output as regulatory compensation rather than intention. Environmental richness buffers this by offering graded novelty and controllable complexity. Circadian organization continues to integrate light temperature feeding and social rhythm into internal timing. Internal clocks distributed across tissues resist abrupt override, smoothing transitions when schedules change. Misalignment fragments rest temporarily until new cues repeat. Health reflects the cumulative balance between demand and recovery rather than isolated events. Stable environments rebuild margin. Persistent unpredictability erodes it gradually. Resilience emerges from the capacity to absorb variation without losing coherence. Aging narrows this capacity slowly. Recovery lengthens. Tolerance bands tighten. Reliance on familiar gradients increases. Exploration yields to monitoring. Regulation persists through simplification rather than collapse. Favored routes and resting zones dominate activity. Sensory engagement remains sufficient to maintain orientation. Integration continues as long as energy supports coordination across systems. Beyond individual bodies, the same dynamics extend into shared landscapes. Repeated movement shapes soil and flooring. Scent fields stabilize travel corridors. Auditory patterns define quiet and active zones. These traces reduce uncertainty for future movement, closing feedback loops between organism and environment. Regulation therefore extends beyond tissue into space itself. No layer governs the whole. Alignment emerges from reciprocal adjustment. Sensing informs response. Response reshapes structure. Structure filters future sensing. The loop remains open. Gradients shift. Patterns settle. Activity rises and fades. Rest returns when demand accumulates. And continuity persists quietly within a body organized for endurance, coordination, and continuous adaptation as conditions continue to change without resolution or endpoint. As these exchanges continue, even small variations accumulate into recognizable rhythms. Temperature drifts across the day. Light angles shift across surfaces. Background sound thickens and thins. The body aligns with these gradients without conscious sequencing. Posture adjusts to reduce pressure points. Resting orientation changes as airflow shifts. Movement timing slides slightly earlier or later as thermal load changes. This constant recalibration preserves comfort while limiting energy cost. No single adjustment carries weight on its own. Stability emerges from their sum. The nervous system maintains this balance by distributing processing rather than centralizing control. Sensory input enters continuously. Thresholds adapt. Relevance filters activate. Only changes that alter outcome retain priority. Repetition lowers signal weight. Novelty raises it briefly, then fades once pattern stabilizes. This dynamic filtering prevents saturation and protects attentional capacity over long durations. Muscular tone follows a similar economy. Baseline tension remains low during rest, rises rapidly with initiation of movement, then releases once demand resolves. Elasticity protects joints by dispersing force across connective tissue rather than concentrating stress at single points. Micro movements during stillness maintain circulation and sensory feedback, preventing stagnation without requiring full activity. Digestion continues quietly in parallel. Blood flow shifts toward the gastrointestinal tract during rest, supporting nutrient absorption and tissue maintenance. During activity, circulation redistributes toward muscle without interrupting baseline function. Hormonal signaling coordinates these transitions gradually, smoothing peaks and preventing abrupt shifts. Energy storage in liver and muscle buffers short-term variation in intake and expenditure, maintaining stable availability without oscillation. Hydration interacts with these systems continuously. Plasma volume influences cardiovascular efficiency. Saliva supports evaporative cooling. Small imbalances appear first as reduced endurance or slower recovery rather than overt distress. Correction unfolds slowly as fluid intake and environmental conditions normalize. Elimination behavior remains synchronized with spatial predictability. Consistent routes and familiar substrates reduce sensory uncertainty during vulnerable moments. In unfamiliar environments, scanning increases and timing delays until mapping restores coherence. This protects stability by avoiding exposure when outcome cannot be predicted. Social context continues to reshape internal thresholds. Shared movement reduces individual scanning demand. Proximity increases sensory input while distributing vigilance across multiple bodies. Spacing restores baseline when stimulation accumulates. These adjustments remain fluid, guided by timing and orientation rather than rigid roles. Acoustic output expands reach when other channels cannot resolve spacing efficiently. Once alignment stabilizes, silence returns to preserve low sensory load. Learning remains embedded within this loop of cost reduction. Behaviors that reduce effort and restore predictability stabilize through repetition. Those that increase load extinguish through lack of reinforcement. Memory retains associations that consistently forecast outcome while releasing outdated correlations. Forgetting preserves flexibility by preventing accumulation of irrelevant detail. Play persists as a recalibration mechanism across adulthood. Variable motion refreshes coordination and timing. Sensory motor coupling remains elastic rather than rigid. Absence of such variability elevates baseline arousal, expressed through pacing or repetitive movement as compensatory regulation rather than intention. Environmental richness buffers this by providing graded novelty and controllable challenge without overwhelming sensory systems. Circadian organization continues to integrate light exposure, temperature feeding, and social rhythm into internal timing. Internal clocks distributed across tissues resist abrupt override, smoothing transitions when schedules shift. Misalignment fragments rest temporarily until new cues repeat and stabilize. Recovery restores coherence through consistency rather than intervention. Health reflects cumulative alignment across these layers. Stable environments rebuild reserve. Chronic unpredictability increases metabolic cost and narrows margin over time. Resilience arises from the ability to absorb variation without losing integration. Aging gradually compresses this margin. Recovery slows. Tolerance bands tighten. Reliance on familiar gradients increases. Exploration yields to monitoring, yet regulation persists through simplification rather than collapse. Favored routes dominate movement. Preferred resting zones stabilize posture and temperature balance. Sensory engagement remains sufficient to maintain orientation even as bandwidth narrows. Integration continues as long as energy supports coordination across systems. Beyond individual bodies, shared spaces retain traces of repeated regulation, compressed soil along common paths, polished surfaces on frequently used thresholds, layered scent fields marking stable corridors. These traces reduce uncertainty for future movement, closing feedback loops between organism and environment. Regulation extends outward into space itself, shaping the conditions that later guide response. No layer commands the whole. Alignment emerges through reciprocal adjustment. Sensing informs response. Response reshapes structure. Structure filters future sensing. The loop remains open. Gradients shift and settle. Activity rises and fades. Rest returns when demand accumulates. Continuity persists quietly within a body organized for endurance, coordination, and distributed regulation as conditions continue to change without resolution and without end point. As continuity holds, regulation remains subtle rather than dramatic. Small corrections accumulate quietly, shaping posture, timing, and spacing without visible effort. Surfaces cool or warm beneath resting weight. Pressure redistributes through joints and muscle fibers. Circulation adapts locally, delivering oxygen and nutrients where micro-demand appears. These changes rarely rise to awareness, yet they maintain mechanical integrity across long spans of repeated movement and rest. Connective tissue responds slowly to habitual load. Collagen fibers align along stress lines. Elasticity preserves range while resisting fatigue. The body learns terrain through tissue remodeling as much as through neural memory. Hills, stairs, uneven ground, and soft flooring each leave a trace in gait preference and joint angle selection. Efficiency emerges from this quiet structural tuning rather than from conscious correction. Sensory sampling continues to anchor orientation. Scent gradients fade and refresh as air currents shift. Chemical traces decay at different rates depending on surface porosity, moisture, and temperature. These decay curves themselves carry information, allowing relative timing of passage to be inferred through repeated exposure. Inhalation patterns adjust subtly to concentration density. Brief pauses appear where signal complexity increases. Speed increases where gradients smooth. Auditory cues layer onto this field. Reverberation patterns define enclosure size. Absorption reveals soft boundaries. Distant mechanical rhythms establish temporal landmarks that stabilize expectation. Once these rhythms repeat, neural filtering reduces their weight, freeing capacity for deviation detection. Visual input contributes primarily through motion boundaries and contrast edges. Shifting shadows signal approaching change long before contact occurs. In low light, reliance shifts further towards scent and sound without loss of orientation. Redundancy preserves continuity even when one channel degrades temporarily. Metabolic regulation remains closely coupled to this sensory economy. Glucose availability stabilizes through hepatic buffering. Fatty acids contribute to sustained output during longer activity phases. Protein turnover supports tissue repair during rest. These processes unfold continuously, guided by hormonal gradients rather than discrete switches. Appetite fluctuates with energy demand and ambient temperature. Warmer conditions suppress intake slightly. Cooler conditions elevate metabolic draw. Learning can modulate timing, yet internal regulation remains primary. Hydration influences circulatory efficiency and thermoregulation in parallel. Reduced plasma volume increases cardiovascular load before overt thirst emerges. Correction restores performance gradually as equilibrium returns. Elimination timing remains coordinated with routine and environmental familiarity. Predictable locations reduce vigilance during vulnerable moments. Unfamiliar settings delay release until spatial mapping restores confidence. This maintains internal stability under uncertainty. Social modulation continues to adjust baseline thresholds. Shared pacing synchronizes movement and reduces individual scanning demand. Proximity increases sensory input while distributing vigilance across multiple bodies. Spacing restores baseline when stimulation accumulates. These negotiations occur fluidly through orientation and timing rather than dominance. Acoustic signaling expands reach when distance cannot be resolved through posture or scent alone. Once alignment stabilizes, vocal output subsides, preserving low sensory load. Learning remains embedded in consequence rather than instruction. Associations strengthen when they reduce effort and restore predictability. Ineffective responses extinguish through lack of reinforcement. Memory remains economical, retaining only what consistently forecasts outcome. Forgetting preserves adaptability by preventing saturation. Play maintains neural and mechanical elasticity across the lifespan. Irregular motion refreshes coordination and sensory coupling. Absence of such variability elevates baseline tension, expressed through pacing or repetitive movement as compensatory regulation rather than intent. Environmental complexity buffers this effect by offering graded novelty without overwhelming sensory demand. Circadian organization continues to integrate light temperature feeding and social rhythm into internal timing. Distributed internal clocks resist abrupt override, smoothing transitions when schedules change. Misalignment fragments rest temporarily until repetition stabilizes new cues. Recovery restores coherence through consistency rather than intervention. Health reflects cumulative alignment rather than isolated events. Stable environments rebuild reserve. Persistent unpredictability erodes margin gradually. Resilience emerges from the capacity to absorb variation without loss of integration. Aging narrows this capacity slowly. Recovery lengthens. Tolerance bands tighten. Reliance on familiar gradients increases. Exploration yields to monitoring. Regulation persists through simplification rather than collapse. Favored routes dominate movement. Preferred resting zones stabilize posture and temperature balance. Sensory engagement remains sufficient to maintain orientation even as bandwidth narrows. Integration continues as long as energy supports coordination across systems. Beyond individual bodies, shared environments retain the imprint of repeated regulation. Compacted pathways, polished thresholds, persistent scent corridors, stable acoustic rhythms. These traces reduce uncertainty for future movement, closing feedback loops between organism and space. Regulation therefore extends outward, shaping the conditions that later guide response. No layer governs the whole. Alignment emerges through reciprocal adjustment. Sensing informs response. Response reshapes structure. Structure filters future sensing. The loop remains open. Gradients shift and settle. Activity rises and fades. Rest returns when demand accumulates. Continuity persists quietly within a body organized for endurance coordination and distributed regulation as conditions continue to change without resolution or endpoint. As this quiet balance continues, even the absence of change becomes informative. Long stretches of stable temperature, consistent sound, and familiar scent fields lower baseline vigilance. Muscle tone softens during rest without sacrificing readiness. Breathing slows slightly while remaining responsive. Circulation redistributes toward maintenance rather than output. These low-demand phases allow tissue repair, immune monitoring, and metabolic recalibration to proceed without interruption. Recovery is not isolated to sleep alone. It unfolds continuously in small increments whenever load decreases. This distributed recovery preserves resilience across long time scales. Sensory systems remain active at reduced intensity. Thresholds rise, filtering repetitive input. Relevance detection stays available if deviation appears. A faint shift in airflow, an unfamiliar odor trace, or an irregular sound briefly elevates posture and orientation. Once assessed, response resolves quickly if no consequence follows. This rapid return prevents accumulation of stress chemistry and preserves energetic margin. Connective tissue benefits from this rhythm of load and release. Microstrain resolves through remodeling rather than injury. Hydration supports elasticity and circulation, maintaining lubrication across joints and fascia. Minor deficits express first as stiffness or slower recovery rather than immediate discomfort. Restoration occurs gradually as fluid balance normalizes. Nutrition continues to interact with structural maintenance. Amino acid availability supports collagen turnover and muscle repair. Lipid metabolism supplies sustained energy during extended movement. Carbohydrate handling stabilizes short-term demand through glycogen buffering. These systems adjust continuously without discrete boundaries between fueling, use, and recovery. Elimination patterns remain synchronized with predictability and safety. Familiar substrates and routes reduce scanning and allow efficient release. Novel environments delay timing until sensory mapping stabilizes, preserving internal coherence under uncertainty. Social modulation persists as a background regulator. Proximity increases shared awareness while distributing vigilance. Spacing restores individual thresholds when stimulation accumulates. Shared rest synchronizes recovery cycles, lowering overall sensory load. Separation allows recalibration when density increases. These adjustments occur without fixed hierarchy when timing and distance remain readable. Acoustic signaling remains sparse under stable conditions. Posture and orientation resolve most spacing requirements. Sound emerges primarily when rapid clarification is needed across distance or obstruction. Once alignment restores, silence resumes, protecting low arousal baseline. Learning continues to refine these dynamics through consequence. Behaviors that lower effort and restore predictability stabilize through repetition. Those that elevate load fade without reinforcement. Memory remains selective, retaining patterns that consistently forecast outcome while allowing irrelevant detail to decay. Forgetting preserves flexibility and prevents saturation. Play remains an adaptive mechanism for recalibration across life stages. Variable motion refreshes coordination timing and sensory integration. Absence of variability elevates baseline tension, expressed through pacing or repetitive engagement as compensatory regulation rather than intention. Environmental richness buffers this by offering graded challenge without excessive stimulation. Circadian organization continues to integrate light exposure, temperature feeding, and social rhythm into internal timing. Distributed clocks resist abrupt override, smoothing transitions when schedules change. Misalignment fragments rest temporarily until repetition stabilizes new cues. Recovery restores coherence through consistency rather than intervention. Health reflects cumulative alignment across systems rather than isolated inputs. Stable environments rebuild reserve. Chronic unpredictability erodes margin gradually. Resilience emerges from the capacity to absorb variation without losing integration. Aging compresses this capacity slowly. Recovery lengthens. Tolerance narrows. Reliance on familiar gradients increases. Exploration yields to monitoring. Regulation persists through simplification rather than collapse. Favored paths dominate movement. Preferred resting zones stabilize posture and thermal balance. Sensory engagement remains sufficient to maintain orientation even as bandwidth narrows. Integration continues as long as energy supports coordination across systems. Beyond individual bodies, shared environments retain signatures of repeated regulation. Compressed pathways, stable scent corridors, familiar acoustic textures, worn resting surfaces. These traces reduce uncertainty for future movement, closing feedback loops between organism and space. Regulation therefore extends beyond tissue into environment itself, shaping the conditions that later guide response. No layer directs the whole. Alignment emerges through reciprocal adjustment. Sensing informs response. Response reshapes structure. Structure filters future sensing. The loop remains open. Gradients shift and settle. Activity rises and fades. Rest returns when demand accumulates. Continuity persists quietly within a body organized for endurance coordination and distributed regulation as conditions continue to change without resolution and without endpoint. As time extends, regulation remains neither static nor linear. Small drift accumulates. Micro-adaptations layer upon one another, reshaping efficiency without altering overall pattern. Muscle recruitment shifts subtly as connective tissue remodels. Preferred angles of joint loading evolve with repeated terrain exposure. Balance strategies refine as vestibular feedback calibrates against accumulated movement history. These changes rarely register as discrete events. They unfold gradually through repetition and constraint. Sensory calibration follows a similar arc. Olfactory sensitivity remains high, yet discrimination thresholds adjust to environmental density. Complex odor fields train the system to prioritize stable markers over transient noise. Auditory filtering becomes more selective as repeated acoustic patterns stabilize baseline. Vision continues to support motion boundary detection even as lighting conditions fluctuate seasonally. Redundancy sustains continuity when any single channel varies. This overlap prevents abrupt loss of orientation and preserves coherence across shifting contexts. Metabolic tuning supports this stability. Mitochondrial density within muscle adapts to habitual load, improving endurance efficiency without increasing peak output. Capillary networks refine distribution, enhancing oxygen delivery where demand recurs most often. Glycogen storage capacity balances between availability and mass economy. Lipid utilization supports longer, steady output without rapid depletion. These biochemical adjustments mirror movement patterns rather than override them. Hydration continues to influence tissue elasticity and circulatory stability. Consistent intake preserves lubrication across joints and fascia. Minor imbalance expresses first as reduced fluidity rather than overt strain. Restoration unfolds quietly through gradual normalization rather than sudden correction. Elimination behavior remains synchronized with spatial familiarity and safety gradients. Predictable routes minimize scanning demand and allow efficient release. Unfamiliar surfaces elevate sampling until confidence returns. This sequencing preserves internal stability by avoiding vulnerability during uncertainty. Social modulation continues to shape baseline thresholds. Synchronized pacing reduces individual vigilance load. Shared rest aligns recovery cycles. Spacing restores equilibrium when sensory density increases. Orientation and timing maintain clarity without requiring escalation. Acoustic signaling remains secondary under stable alignment. Posture and movement resolve most spatial negotiation. Sound emerges primarily when rapid clarification is required beyond visual or chemical range. Once alignment stabilizes, vocal output diminishes, preserving low sensory load. Learning remains embedded within this continuous optimization. Associations that reduce metabolic cost stabilize. Those that increase effort fade without reinforcement. Memory retains only patterns that reliably predict outcome. Forgetting releases outdated correlations, preventing saturation and preserving responsiveness. Play continues to recalibrate sensory motor coupling across the lifespan. Irregular motion refreshes coordination and timing. Absence of variability elevates baseline arousal, expressed through pacing or repetitive engagement as regulatory compensation rather than intention. Environmental richness buffers this effect by offering graded novelty and controllable complexity. Circadian integration persists through distributed internal clocks that align light temperature feeding and social rhythm. Abrupt schedule shifts fragment rest temporarily until repetition stabilizes new cues. Recovery restores coherence through consistency rather than intervention. Health reflects cumulative balance across load recovery and environmental predictability rather than isolated events. Stable contexts rebuild margin. Chronic unpredictability erodes reserve gradually. Resilience arises from the ability to absorb variation without loss of integration. Aging compresses this margin slowly. Recovery lengthens. Tolerance bands narrow. Reliance on familiar gradients increases. Exploration yields to monitoring. Regulation persists through simplification rather than collapse. Favored routes dominate movement. Preferred resting zones stabilize posture and thermal balance. Sensory engagement remains sufficient to maintain orientation even as bandwidth narrows. Integration continues as long as energy supports coordination across systems. Beyond individual bodies, shared environments retain imprints of repeated regulation. Compacted soil, polished thresholds, layered scent corridors, stabilized acoustic textures. These traces reduce uncertainty for future movement, closing feedback loops between organism and space. Regulation therefore extends outward, shaping the conditions that later guide response. No layer governs the whole. Alignment emerges through reciprocal adjustment. Sensing informs response. Response reshapes structure. Structure filters future sensing. The loop remains open. Gradients shift and settle. Activity rises and fades. Rest returns when demand accumulates. Continuity persists quietly within a body organized for endurance coordination and distributed regulation as conditions continue to change without resolution or endpoint. As continuity unfolds without emphasis, regulation remains present in the smallest transitions. A slight change in floor temperature shifts resting orientation. A faint draft redirects positioning by a few centimeters. An unfamiliar trace carried on air narrows movement briefly before dissipating. None of these moments accumulate into tension when predictability remains intact. Each resolves quietly through proportional adjustment. The nervous system favors minimal correction, conserving metabolic reserve for conditions that truly require output. This proportionality stabilizes internal chemistry. Cortisol release remains low under predictable variation. Immune monitoring proceeds without diversion. Tissue maintenance continues uninterrupted. Recovery therefore becomes a background process rather than a discrete event. Elasticity in muscle and fascia benefits from this steady alternation between low load and moderate engagement. Micro tears repair without inflammation. Circulation refreshes nutrient delivery without strain. Hydration maintains lubrication and thermal balance across all compartments. Small deviations correct through routine rather than intervention. Sensory sampling remains active yet economical. Inhalation depth modulates with odor density. Auditory filtering suppresses repeated patterns while preserving sensitivity to irregular timing. Visual scanning reduces amplitude when contrast remains stable, conserving neural bandwidth. Redundancy across channels prevents over-reliance on any single input stream. If one signal degrades temporarily, orientation persists through overlap rather than compensation effort. This buffering protects coherence under shifting light, weather, and acoustic texture. Metabolic systems mirror this distributed logic. Energy flows adjust through hormonal gradients rather than binary switches. Insulin and glucagon balance glucose availability. Fatty acid mobilization supports extended output. Amino acid turnover maintains tissue integrity. These adjustments occur continuously and invisibly, maintaining stable function without oscillation. Elimination rhythms remain synchronized with spatial predictability and safety gradients. Consistent substrates reduce scanning demand and support relaxed release. Unfamiliar terrain elevates sampling until confidence returns. This sequencing preserves internal stability during uncertainty without requiring heightened arousal. Social modulation continues to refine baseline thresholds. Synchronized movement reduces individual vigilance cost. Shared rest aligns recovery cycles. Spacing restores equilibrium when sensory density increases. Timing and orientation maintain clarity without escalation. Acoustic signaling remains sparse under stable alignment. Posture resolves most spacing negotiation efficiently. Sound emerges primarily when distance cannot be resolved through other channels. Once alignment stabilizes, silence returns, preserving low sensory load. Learning continues through consequence rather than instruction. Adjustments that lower effort stabilize through repetition. Those that elevate cost fade through lack of reinforcement. Memory remains economical, retaining patterns that reliably forecast outcome while releasing outdated associations. Forgetting preserves adaptability and prevents saturation. Play sustains neural and mechanical flexibility across life stages. Irregular motion refreshes coordination, timing, and sensory coupling. Absence of variability elevates baseline arousal, expressed through pacing or repetitive engagement as regulatory compensation rather than intent. Environmental richness buffers this effect by offering graded novelty without excessive stimulation. Circadian organization integrates light temperature feeding and social rhythm into internal timing. Distributed internal clocks resist abrupt override, smoothing transitions when schedules shift. Misalignment fragments rest temporarily until repetition stabilizes new cues. Recovery restores coherence through consistency rather than intervention. Health reflects cumulative alignment rather than isolated variables. Stable contexts rebuild reserve. Chronic unpredictability erodes margin gradually. Resilience arises from the capacity to absorb variation without losing integration. Aging narrows this capacity slowly. Recovery lengthens. Tolerance bands tighten. Reliance on familiar gradients increases. Exploration yields to monitoring. Regulation persists through simplification rather than collapse. Favored routes dominate movement. Preferred resting zones stabilize posture and thermal balance. Sensory engagement remains sufficient to maintain orientation even as bandwidth narrows. Integration continues as long as energy supports coordination across systems. Beyond individual bodies, shared environments retain signatures of repeated regulation, compacted pathways, persistent scent corridors, stabilized acoustic textures, worn resting surfaces. These traces reduce uncertainty for future movement, closing feedback loops between organism and space. Regulation therefore extends beyond tissue into environment itself, shaping the conditions that later guide response. No layer directs the whole. Alignment emerges through reciprocal adjustment. Sensing informs response. Response reshapes structure. Structure filters future sensing. The loop remains open. Gradients shift and settle. Activity rises and fades. Rest returns when demand accumulates. Continuity persists quietly within a body organized for endurance, coordination, and distributed regulation as conditions continue to change without resolution and without endpoint. As the loop continues without emphasis, even minor sensory drift becomes part of stability rather than disruption. Seasonal humidity alters scent persistence. Temperature gradients shift resting preference by subtle margins. Background sound density thickens or thins with surrounding activity. Each variation is absorbed through small proportional correction rather than accumulated tension. The nervous system maintains low gain when predictability remains intact, allowing internal chemistry to remain balanced and recovery to proceed continuously. Muscle tone adjusts gently with posture shifts. Connective tissue distributes load across changing angles, preserving joint integrity over long spans. Circulation adapts locally to micro-demand, delivering nutrients and oxygen without overshoot. Hydration maintains lubrication and thermal buffering across compartments, smoothing mechanical interaction between tissues. Sensory sampling remains efficient. Inhalation patterns adapt to odor density. Auditory filtering suppresses repeated rhythms while preserving sensitivity to timing irregularity. Visual processing remains tuned to contrast boundaries rather than detail, conserving neural bandwidth in low information environments. Redundancy across channels preserves orientation even when one stream degrades temporarily. This overlap prevents abrupt instability and reduces compensatory effort. Metabolic regulation mirrors this distributed logic. Glucose availability stabilizes through hepatic buffering. Lipid mobilization supports sustained output. Protein turnover maintains structural integrity. Hormonal gradients coordinate these flows continuously without discrete switching. Elimination behavior remains synchronized with spatial predictability and safety gradients. Consistent substrates reduce scanning demand and support relaxed release. Unfamiliar contexts elevate sampling until mapping restores confidence. This sequencing protects internal coherence during uncertainty. Social modulation continues to refine baseline thresholds. Synchronized pacing reduces individual vigilance load. Shared rest aligns recovery cycles. Spacing restores equilibrium when sensory density increases. Timing and orientation maintain clarity without escalation. Acoustic signaling remains sparse under stable alignment. Posture resolves most spacing negotiation efficiently. Sound emerges primarily when distance cannot be resolved through other channels. Once alignment stabilizes, silence resumes, preserving low sensory load. Learning remains embedded within this continuous optimization. Associations that reduce metabolic cost stabilize through repetition. Those that increase effort fade without reinforcement. Memory remains selective, retaining patterns that reliably forecast outcome. Forgetting preserves adaptability and prevents saturation. Play sustains neural and mechanical flexibility across life stages. Variable motion refreshes coordination and timing. Absence of variability elevates baseline arousal, expressed through pacing or repetitive engagement as regulatory compensation rather than intent. Environmental richness buffers this by offering graded novelty without excessive stimulation. Circadian organization integrates light temperature feeding and social rhythm into internal timing. Distributed clocks resist abrupt override, smoothing transitions when schedules change. Misalignment fragments rest temporarily until repetition stabilizes new cues. Recovery restores coherence through consistency rather than intervention. Health reflects cumulative alignment rather than isolated variables. Stable contexts rebuild reserve. Chronic unpredictability erodes margin gradually. Resilience arises from the capacity to absorb variation without losing integration. Aging narrows this capacity slowly. Recovery lengthens. Tolerance bands tighten. Reliance on familiar gradients increases. Exploration yields to monitoring. Regulation persists through simplification rather than collapse. Favored routes dominate movement. Preferred resting zones stabilize posture and thermal balance. Sensory engagement remains sufficient to maintain orientation even as bandwidth narrows. Integration continues as long as energy supports coordination across systems. Beyond individual bodies, shared environments retain signatures of repeated regulation, compacted pathways, persistent scent corridors, stabilized acoustic textures, worn resting surfaces. These traces reduce uncertainty for future movement, closing feedback loops between organism and space. Regulation therefore extends beyond tissue into environment itself, shaping the conditions that later guide response. No layer directs the whole. Alignment emerges through reciprocal adjustment. Sensing informs response. Response reshapes structure. Structure filters future sensing. The loop remains open. Gradients shift and settle. Activity rises and fades. Rest returns when demand accumulates. Continuity persists quietly within a body organized for endurance coordination and distributed regulation as conditions continue to change without resolution and without endpoint. As continuity remains uninterrupted, the system favors conservation over amplification. Effort stays proportional to demand. Reserves accumulate slowly during low-load periods. These reserves buffer future variability without requiring overt compensation. Connective tissue benefits from this restraint. Microstrain resolves through remodeling rather than inflammation. Joint surfaces maintain lubrication through steady movement and hydration. Cartilage absorbs compression and releases it gradually, protecting underlying bone across repeated cycles. Circulation adapts locally to pressure gradients, delivering nutrients where micro-repair occurs. Capillary density supports diffusion efficiency without excessive cardiac load. These small efficiencies accumulate into long-term durability rather than peak performance. Sensory calibration continues to refine thresholds. Olfactory sampling remains primary, yet discrimination sharpens towards stable markers rather than transient noise. Repeated exposure trains filtering mechanisms to preserve relevance while reducing cognitive cost. Auditory processing emphasizes timing and direction over amplitude, allowing orientation without saturation. Visual processing remains anchored to motion boundaries and contrast gradients, conserving neural bandwidth in low information contexts. Redundancy across channels preserves continuity under shifting environmental conditions. When one stream degrades temporarily, overlap sustains orientation without escalation. Metabolic regulation mirrors this distributed stability. Hepatic buffering maintains glucose availability within narrow range. Lipid mobilization supports extended activity without rapid depletion. Protein turnover preserves structural integrity during rest cycles. Hormonal gradients coordinate these flows continuously rather than through abrupt switching. Hydration influences all compartments simultaneously. Plasma volume stabilizes circulation. Interstitial fluid preserves tissue elasticity. Saliva supports evaporative cooling. Minor imbalance expresses first as reduced endurance rather than immediate distress. Restoration unfolds quietly as intake and environmental conditions normalize. Elimination rhythms remain synchronized with spatial predictability and safety gradients. Consistent substrates minimize scanning demand and support relaxed release. Unfamiliar contexts elevate sampling until mapping restores confidence. This sequencing protects internal coherence during uncertainty. Social modulation continues to adjust baseline thresholds. Synchronized movement reduces individual vigilance load. Shared rest aligns recovery cycles. Spacing restores equilibrium when sensory density increases. Orientation and timing maintain clarity without escalation. Acoustic signaling remains sparse under stable alignment. Posture resolves most spacing negotiation efficiently. Sound emerges primarily when distance cannot be resolved through other channels. Once alignment stabilizes, silence resumes, preserving low sensory load. Learning remains embedded within continuous optimization. Associations that reduce metabolic cost stabilize through repetition. Those that increase effort fade through lack of reinforcement. Memory remains selective, retaining patterns that reliably forecast outcome. Forgetting preserves adaptability and prevents saturation. Play sustains neural and mechanical flexibility across life stages. Variable motion refreshes coordination and timing. Absence of variability elevates baseline arousal, expressed through pacing or repetitive engagement as regulatory compensation rather than intent. Environmental richness buffers this by offering graded novelty without excessive stimulation. Circadian organization integrates light temperature feeding and social rhythm into internal timing. Distributed clocks resist abrupt override, smoothing transitions when schedules change. Misalignment fragments rest temporarily until repetition stabilizes new cues. Recovery restores coherence through consistency rather than intervention. Health reflects cumulative alignment rather than isolated variables. Stable contexts rebuild reserve. Chronic unpredictability erodes margin gradually. Resilience arises from the capacity to absorb variation without losing integration. Aging narrows this capacity slowly. Recovery lengthens. Tolerance bands tighten. Reliance on familiar gradients increases. Exploration yields to monitoring. Regulation persists through simplification rather than collapse. Favored routes dominate movement. Preferred resting zones stabilize posture and thermal balance. Sensory engagement remains sufficient to maintain orientation even as bandwidth narrows. Integration continues as long as energy supports coordination across systems. Beyond individual bodies, shared environments retain signatures of repeated regulation. Compacted pathways, persistent scent corridors, stabilized acoustic textures, worn resting surfaces. These traces reduce uncertainty for future movement, closing feedback loops between organism and space. Regulation therefore extends beyond tissue into environment itself, shaping the conditions that later guide response. No layer directs the whole. Alignment emerges through reciprocal adjustment. Sensing informs response. Response reshapes structure. Structure filters future sensing. The loop remains open. Gradients shift and settle. Activity rises and fades. Rest returns when demand accumulates. Continuity persists quietly within a body organized for endurance coordination and distributed regulation as conditions continue to change without resolution and without endpoint. As the cycle sustains itself, even the smallest feedback loops contribute to long-term coherence. Subtle variations in pressure across the pause refine proprioceptive calibration. Micro-slips on smooth surfaces adjust muscle recruitment without conscious correction. Repeated contact with different textures reshapes tactile sensitivity, improving discrimination where it matters most for stability. These refinements accumulate slowly, enhancing efficiency without increasing output. Neural pathways strengthen around reliable sensory motor couplings, reducing processing cost and reaction latency. This quiet optimization preserves reserve for unpredictable change. Respiratory patterns remain adaptable within narrow margins. Tidal volume adjusts with posture and movement. Panting transitions smoothly as thermal load increases. Gas exchange remains stable due to elastic lung tissue and synchronized rib movement. Oxygen delivery remains sufficient without overventilation, conserving hydration and minimizing thermal stress. Cardiovascular response mirrors this proportionality. Stroke volume increases gently with sustained activity. Peripheral resistance adapts locally, distributing flow according to tissue demand. Recovery begins as soon as load decreases rather than waiting for full cessation. This continuous modulation preserves vascular flexibility across lifespan. Digestive timing integrates with these rhythms. Gastric emptying slows during activity and accelerates during rest, optimizing nutrient absorption without competing with locomotor demand. Intestinal motility maintains steady throughput, preventing stagnation while preserving extraction efficiency. Hepatic metabolism balances short-term glucose availability with longer-term lipid utilization, smoothing energy flow across fluctuating demand. Hydration continues to influence plasma viscosity and heat transfer. Adequate fluid maintains circulatory efficiency and tissue compliance. Mild deficit elevates effort cost before subjective discomfort emerges. Correction restores performance gradually as balance normalizes. Elimination behavior remains tuned to environmental safety gradients. Predictable routes and substrates minimize vulnerability during release. Unfamiliar contexts elevate scanning until spatial mapping stabilizes. This sequencing preserves internal coherence under uncertainty without triggering excessive arousal. Social modulation remains embedded in baseline regulation. Shared movement synchronizes pacing and reduces individual scanning cost. Proximity increases sensory input while distributing vigilance across multiple bodies. Spacing restores equilibrium when density increases. Orientation and timing maintain clarity without hierarchy. Acoustic signaling remains sparse under stable alignment. Posture resolves most spacing negotiation efficiently. Sound emerges primarily when rapid clarification is needed beyond visual or chemical range. Once alignment stabilizes, silence resumes, preserving low sensory load. Learning continues to refine these processes through consequence. Patterns that reduce energetic cost stabilize through repetition. Those that increase load fade through lack of reinforcement. Memory retains associations that reliably forecast outcome while releasing outdated correlations. Forgetting preserves adaptability and prevents saturation. Play remains a mechanism for recalibration across adulthood. Irregular motion refreshes coordination timing and sensory coupling. Absence of variability elevates baseline arousal, expressed through pacing or repetitive engagement as regulatory compensation rather than intent. Environmental complexity buffers this by offering graded novelty and controllable challenge. Circadian integration persists through distributed internal clocks, aligning light temperature feeding and social rhythm. Abrupt schedule changes fragment rest temporarily until repetition stabilizes new cues. Recovery restores coherence through consistency rather than intervention. Health reflects cumulative balance across these layers rather than isolated variables. Stable environments rebuild reserve. Chronic unpredictability erodes margin gradually. Resilience arises from the capacity to absorb variation without losing integration. Aging narrows this capacity slowly. Recovery lengthens. Tolerance bands tighten. Reliance on familiar gradients increases. Exploration yields to monitoring. Regulation persists through simplification rather than collapse. Favored routes dominate movement. Preferred resting zones stabilize posture and thermal balance. Sensory engagement remains sufficient to maintain orientation even as bandwidth narrows. Integration continues as long as energy supports coordination across systems. Beyond individual bodies, shared environments retain imprints of repeated regulation. Compacted pathways, layered scent corridors, stabilized acoustic textures, worn resting surfaces. These traces reduce uncertainty for future movement, closing feedback loops between organism and space. Regulation therefore extends beyond tissue into environment itself, shaping the conditions that later guide response. No layer governs the whole. Alignment emerges through reciprocal adjustment. Sensing informs response. Response reshapes structure. Structure filters future sensing. The loop remains open. Gradients shift and settle. Activity rises and fades. Rest returns when demand accumulates. Continuity persists quietly within a body organized for endurance coordination and distributed regulation as conditions continue to change without resolution or endpoint. As subtle variation continues to accumulate, structural diversity across the species becomes visible without altering the underlying regulatory pattern. Body size influences stride length and heat exchange. Coat density modifies insulation and airflow across skin. Muzzle length shapes airflow dynamics and cooling efficiency. Limb proportion alters mechanical leverage and ground contact timing. These differences shift local thresholds while preserving the same distributed logic of sensing adjustment and response. Efficiency adapts to form rather than overriding it. In cooler seasons, photoperiod shortens. Light exposure decreases gradually. Internal clocks respond through hormonal signaling that reshapes sleep timing, appetite, and coat turnover. Hair growth cycles shift toward thicker insulation. Shedding redistributes fiber density as temperature gradients change. Skin maintains barrier function while supporting microbial communities that contribute to immune balance and odor signature. These surface ecosystems respond slowly to humidity, temperature, and grooming patterns, stabilizing against abrupt fluctuation. Immune surveillance operates continuously at low intensity. Minor tissue stress activates localized repair without systemic diversion. Lymphatic flow clears metabolic byproducts and supports fluid balance. Inflammation remains proportional when predictability holds. Recovery integrates quietly into daily movement and rest rather than appearing as isolated event. In denser environments, sensory complexity increases. Overlapping scents compress gradients. Persistent mechanical noise thickens the auditory background. Artificial light extends visual exposure beyond natural cycles. Adaptation emerges through filtering rather than resistance. Thresholds rise for constant input. Selectivity sharpens for deviation. Timing shifts toward quieter intervals when possible. Route selection favors corridors with stable texture and predictable airflow. These choices reduce cumulative load without requiring structural change. In open landscapes, gradients stretch wider. Scent persistence varies with wind and ground cover. Sound travels farther with fewer reflections. Visual contrast shifts more sharply with weather and sun angle. Orientation relies more heavily on long-range sampling and memory integration. Yet the same principles apply: proportional correction, redundancy across channels, conservation of reserve. Developmental plasticity supports this adaptability. Early exposure shapes threshold calibration and motor mapping. Repeated terrain contact tunes connective tissue and joint alignment. Sensory weighting adjusts based on reliability of input during growth. These calibrations persist into maturity while remaining adjustable through continued exposure. Aging modifies plasticity rate rather than eliminating it. Adjustment continues at slower tempo. Recovery extends. Margins narrow. Simplification preserves coherence. Social composition also influences regulatory load. Group size alters spacing tolerance and acoustic density. Shared routines compress uncertainty. Variable membership increases sampling demand. Alignment stabilizes through repetition rather than hierarchy. Timing and orientation resolve most negotiation efficiently. Feeding ecology contributes additional rhythm. Meal timing entrains digestive hormone cycles. Nutrient composition modulates microbial balance and metabolic efficiency. Gradual change integrates smoothly. Abrupt change increases variability until new patterns stabilize. Water availability shapes activity timing and thermoregulation without requiring conscious prioritization. Mild scarcity elevates conservation behavior before physiological strain appears. Restoration reverses these shifts gradually through consistent access. Across all these layers, the same quiet loop persists. Sensing guides adjustment. Adjustment reshapes movement. Movement filters future sensing. No central directive governs the sequence. Coherence emerges from constraint and repetition. Gradients drift. Thresholds recalibrate. Structure adapts. Activity expands and contracts. Rest restores capacity. Alignment continues without announcement or closure. Suitable for repetition. Suitable for continuity. Suitable for returning again to the same slow exchange between environment and a body organized for endurance coordination and distributed regulation within changing conditions. As the cycle continues toward no fixed boundary, the remaining variations settle into the same quiet exchange. Temperature shifts soften across surfaces. Air density changes with night cooling and early warmth. Background sound thins and thickens without altering orientation. Scent layers drift and reform, carrying memory forward while releasing what no longer holds relevance. Posture follows these gradients gently. Weight redistributes. Muscle tone rises and releases. Circulation adapts locally without drawing attention. Energy moves where demand appears, then returns to maintenance when demand fades. Hydration preserves elasticity and flow. Connective tissue absorbs load and restores length. Neural thresholds filter repetition while preserving readiness for change. Nothing accumulates beyond what can be absorbed. Nothing accelerates beyond what can be sustained. Spacing remains readable. Timing remains predictable. Alignment holds through proportional response rather than effort. Rest returns whenever load recedes. Light dozing blends into stillness. Sensory sampling softens yet remains present. Faint deviation lifts orientation briefly, then resolves as gradients stabilize. Learning continues to refine efficiency through repetition. Memory retains only what consistently reduces uncertainty. Outdated patterns dissolve quietly without disruption. Play and variation preserve elasticity across motion and sensing. preventing rigidity without introducing excess stimulation. Circadian rhythm integrates remaining cues of light temperature feeding and proximity, maintaining temporal coherence across shifting conditions. Aging narrows margins gently, favoring conservation and familiar gradients, yet regulation persists through simplification rather than loss. Favored routes remain stable. Preferred resting zones maintain thermal balance and pressure distribution. Sensory engagement remains sufficient to support orientation even as bandwidth contracts. Integration continues as long as energy supports coordination across systems. Shared environments retain traces of repeated passage, smoothed thresholds, layered scent corridors, softened acoustic textures. These imprints lower uncertainty for subsequent movement, extending regulation beyond the body into space itself. No single layer directs the exchange. Sensing informs adjustment. Adjustment reshapes structure. Structure filters future sensing. The loop remains open and unmarked by endpoint. Gradients shift and settle. Activity rises and fades. Rest returns when demand accumulates. Continuity persists quietly within a body organized for endurance coordination and distributed regulation, ready to repeat, ready to resume, moving without urgency, resting without finality, remaining aligned within changing conditions as long as energy continues to circulate and gradients continue to form and dissolve.